Artificial intelligence, AI, has become a cornerstone of modern technology, influencing industries from healthcare to finance and even our daily lives. But what exactly makes AI work? At its core, AI relies on algorithms, step-by-step computational procedures designed to solve problems or perform tasks. In this script, we'll demystify the basics of AI algorithms, exploring their key types, how they work, and why they matter. AI algorithms are the building blocks of artificial intelligence systems. They allow machines to process data, identify patterns, and make decisions. Unlike traditional programming, where every step is predefined by a developer, AI algorithms often learn and adapt over time. This ability to learn is what makes AI powerful and versatile. There are several categories of AI algorithms, each suited to different tasks. Let's explore the three main types. Supervised learning is like teaching a student with a set of labeled examples. The algorithm is trained on input-output pairs, where the input is data and the output is the correct answer. For instance, if you're teaching a model to recognize cats in images, you'd provide it with many labeled images of cats and non-cats. Common algorithms include linear regression, used for predicting numerical values, support vector machines, SVM, used for classification tasks, and neural networks, which mimic the human brain and excel at tasks like image recognition. Unsupervised learning works without labeled data. The goal is to find hidden patterns or structures in the data. This is often used in exploratory tasks or when labels are unavailable. Common algorithms include k-means clustering, which groups data into clusters based on similarities, and principal component analysis, PCA, which reduces the dimensionality of data while preserving important features. Reinforcement learning mimics the way humans learn from feedback. An agent interacts with an environment, takes actions, and learns to achieve goals by maximizing rewards and minimizing penalties. Key components include the agent, which is the learner or decision-maker, the environment, which is everything the agent interacts with, and the reward signal, which is feedback that guides learning. An example is teaching a robot to navigate a maze by rewarding it for reaching the exit and penalizing it for hitting walls. At a high level, AI algorithms work in three main steps: data collection and pre-processing, where AI algorithms require data to learn from various sources like sensors, databases, or the internet, and pre-processing involves cleaning, normalizing, and organizing the data for analysis, training the model, where the algorithm learns from the data, finding patterns that map inputs to outputs for supervised learning, or identifying clusters or structures for unsupervised learning, and prediction and evaluation, where after training, the model is used to make predictions or decisions, and the accuracy and performance of the model are evaluated using metrics like accuracy, precision, recall, and F1 score. AI algorithms power countless applications that make our lives easier and more efficient. Examples include healthcare, where they diagnose diseases from medical images using convolutional neural networks, CNNs. Finance, where they detect fraudulent transactions with anomaly detection algorithms. Entertainment, where they recommend movies and songs through collaborative filtering. And autonomous vehicles, which enable self-driving cars to perceive and navigate their surroundings. Despite their immense potential, AI algorithms have limitations. They are data-dependent, needing large amounts of high-quality data, which can be expensive and time-consuming to gather. They can be biased if the training data is biased. They often lack interpretability, especially deep learning models, which act as black boxes, making it hard to understand how they make decisions. And they can have a high computational cost, as training complex models can require significant computational resources. The field of AI is rapidly evolving, with advancements focusing on explainable AI, XAI, which aims to make AI decisions more transparent and understandable. Federated learning, which enables AI to learn across decentralized data sources while preserving privacy. Energy-efficient algorithms, which aim to reduce the environmental impact of AI training. And general AI, which seeks to develop algorithms that can perform a wide range of tasks, much like human intelligence. Understanding the basics of AI algorithms is essential in today's technology-driven world. These algorithms form the foundation of systems that revolutionize industries and improve our lives. While challenges remain, Ongoing research promises to make AI even more accessible, efficient, and impactful. As we continue to explore and innovate, the possibilities for AI are virtually limitless.